Live is cool.
I don't know what that means.
Check the sound. Output, input, use this microphone.
Okay, we are live now.
What's wrong?
Would you have a second computer? Yuguang, can you hear
Try
me?
again. Really?
Yeah, usually what does that green thing? It rings. You can
Okay.
see what dogs.
I can hear you guys.
Oh, okay.
Yuguang, would you have a second computer? So you can project the slides
Why?
and you are able to see you guys.
There's something wrong with the audio of your whole machine because it's not.
Okay.
Do
we have another computer in the room?
Oops, why?
Okay, I see the message.
I don't know why.
He doesn't know that we still can't hear.
So last time it worked good, worked well, but this time.
You want to try rebooting?
Uh-huh.
You want to try rebooting?
I hear you guys fine.
Could you send me that link, or did you send an email?
There.
Or just send it to the list?
Yes, he has sent us.
Can you just invite me?
Yeah, it's like
Why?
Oh, sent to this thing.
Where to invite people? I'm not good at Google Hangout. Cool.
Okay, who can hear me?
okay. I don't hear anything from you guys. I can see the camera, but I don't get any audio now. Okay.
No, he just, because of the...
Okay, I hear now.
He has the microphone.
Okay, I think, can you hear us?
Yes, perfect.
Say something, please.
Sorry, what was the question?
Can mute this.
Oh, we can't hear. We're gonna plug it in.
Yes, we can't. Maybe something wrong with just plugging.
Is it on? That speaker?
Yeah. All right.
The speaker of the room should be turned on with the projector. If you see the projector, the
We
speaker.
can't hear you when you turn on the speakers, Michelle.
Okay.
Okay.
Whoops.
Is the microphone in John's computer?
I think we can't.
Okay, go ahead.
I think we can't use the plugging the speaker in this room. So we can
Can
only
you hear from the laptop?
or we can just use my computer when I.
Oh, Michelle's thing is working.
Yeah. Yes. We don't use that one. I use my internal audio.
So can you hear us?
Yes.
Cool.
Are you using the microphone that we bought?
Yes, we're using that, but we can't use the plugin of this room, the audio or the video. Let's try the video. I think when I use the video, the sound will disappear.
Okay.
Let's try.
Yes, because the audio, it's only going to work if the projector is working.
Oh, okay.
I mean, the speakers.
Can say something, please?
Yeah, sure. Can you hear me?
Sure. I think we better use the. Yes, use my internal. Use my Mac's audio instead of the speaker of the room.
If you guys can hear me, it's fine.
Yeah.
Yeah.
We can hear you.
Let's go.
So I think we can start.
Yes. Are you going to have another computer to project the slides?
Yes. I use mine and to project it on the wall. So and
Well, I need the slide to be on the Hangout so I can follow it.
He needs the slides.
oh yeah. Sorry. It's my time to do this. Can everybody see my slides?
I can.
Okay, great. So today I'm going to present a paper that John mentioned in my last talk. And this is something about XCP, Explicitly Control Protocol. This protocol is designed for the congestion control for high bandwidth delay networks. This kind of networks has a nickname or something called long fat network. You can imagine that they have a very fat terminal and you have to wait a very long time, and that's a delay, right? So today I'm going to talk about something about this XCP. And at the first slide, I will give you some notations I will use in later slides to give you convenience to understand this. This XCP means Explicitly Control Protocol. RTT means round trip time, and CWD means congestion window size. It's size, not congestion window.
Did you change the slides?
Uh-huh.
Because I'm still seeing the first one.
The first one?
Yes, congestion.
Yeah.
No, you paged forward. You don't see notations, Michelle?
Can you see this notation? Notation slide.
No, I only see the title slide. Are you projecting and using the same computer for the slides?
Yes. Yes, I'm using my Mac to project, and then use also my computer to show this slide.
Why don't you just send him the slides so you can follow along? Just send him the PowerPoint.
Okay.
Or I send you the PowerPoint and you can. you can see it. Or I don't play this PowerPoint, or I just show like this.
Can you see this, Michelle?
Yeah, I'm seeing that. Yes.
Can you see notations right now?
Yeah, now I see the notations.
Okay, we'll just do it that way.
Okay, sure. So this is some notations. That CWND means congestion window size, and S donate the package size, and EC called efficiency controller, and FC called fairness controller. And this is some interesting concept this paper introduced. They decoupled the regular fairness controller to be two controller. One is called efficient controller, and the other one is fairness controller. And I will give details later in this slide. And here is the outlines. At the very beginning, I will give some introduction about XCP. And I will mainly talk about why we don't want to use TCP in this long-fat network. And I will give some comparison about TCP and XCP. And then I will give details about XCP's specification. And it will include first the framework, the XCP framework, and then the behavior of the XCP sender and the XCP receiver. And then I will give you some control law of this XCP router. That's about the two controllers, efficient controller and the fairness controller, some mathematical model. And at the third part, I will introduce something about TCP friendly. In the very last part, they gave some modify to their efficient controller and make it TCP friendly. And the fourth part, I will present some simulation results of XCP. And in the fifth part, and I have some idea. I came up with some idea why XCP is a good candidate for XIA global congestion control. We can have discussion here, and you can give your thoughts and your idea about this. And the last part is a question and answer. So this is the introduction. And here I list some drawbacks of the TCP in the long-fat network. In this paper, they gave a lot of evidence why TCP is not a good candidate for this kind of networks. They list a lot of TCP schemes. Like the first two is for the queue scheme. The first one is the red queue, random early discard, and the third one is some controller called proportional integral. Because if you're familiar with control theory, we usually use proportional, integral, and differential controller. This is that, and we can see that TCP's performance when the delay and the bandwidth go up and up, the stability of all this scheme all go to instability and or oscillatory, and the efficiency tends to be not good as well. So why?
Can you be more precise about what you mean by stability and efficiency?
Yeah.
Know lots of different measures of both.
Yeah, sure.
I kind of know this paper, but I think somebody watching isn't really going to.
Yeah.
Unstable, inefficient.
So this
needs a picture.
Okay.
Or something, or a definition.
If you're familiar with control theory, this instability means when we have a control system, and the instability means your output will not converge to something. It will turn to something weird or to infinity. That's called instability. And this oscillatory means the result will up and down very frequently. And about this efficiency, I say here, this efficiency is about in this high bandwidth and high delay network, there will be a lot of packages in one RTT. So if we use TCP, in one RTT, there will be a lot of packages, and TCP will drop a lot of things, and that will result in TCP will miss a lot of feedback packages. So it leads to that TCP works not very efficiently.
Yeah, I mean, I think the very basic reason for inefficiency, if you boil it right down to it, the throughput of TCP is proportional to 1 over the round-trip time.
Yeah.
So this means that if the channel characteristics give a short fat pipe, you get 1 value throughput for it. This can handle, some number of bits per second.
Yes.
And just by making the pipe longer, somehow that causes the TCP throughput to drop.
Yes.
Not because the channels change, just because the pipe's longer. So this is what kind of all formula congestion control papers have this type of dependency.
Yeah.
So when people say TCP is inefficient, they mean that. They usually do.
Okay.
High level.
Yeah. Okay. Got it.
These TCP schemes, that column, those are just algorithms for congestion control in TCP?
The first two is something called active queue management, because when we do some congestion control, we need to consider the queue. So this is the scheme for the queue. So the very simple one we use the queue is drop tail. When some package want to join the queue, then this queue, so we drop the tail. But this queue shows here is more advanced. They have their randomly model. They have a probability model to estimate the queue and drop wisely, I think.
Okay.
Yeah.
There's a whole variety of different methods for TCP congestion control. The first are AQM schemes. The next ones are rate-based. Then there are rate-based and window-based schemes that change the end-to-end congestion control by trying to modulate the rate in a different way than additive increase, multiplicative decrease, or try to do a different windowing scheme that TCP uses. But yeah, and a lot of them have. They all run into kind of fundamental difficulties.
So in their paper, they gave reference to Audist and showed Audist paper shows that if TCP work in these long-fat networks, at last they will cause all the problems of stability and efficiency. And next, I will give some XCP in comparison. So the first one, I think, the XCPs also use control theory framework. They use feedback to implement this control. And the second one is the most interesting concept, I think. They decoupling the utilization control from the fairness. This utilization control means that efficient controller. It used 2 controllers to implement this control, this congestion control. And the third is XCP works well, remaining efficient, fair, and stable as the link or the delay increases. So the fourth one is distinguish error loss from the congestion loss. Why this? Because XCP use some efficiency controller. This controller will decrease the queue size. So in XCP, if we use XCP, package seldom drop. So here, if we have something lost or the package lost, we assume that there will be something error. It's it is not caused by congestion. It's caused by some error, right? And the last one is detecting the misbehavior source, because XCP is explicitly control protocol. It gave explicitly feedback to every source, so we can detect which source gave the bad behavior. So this is also good for security, I think. So because all the read control algorithms are very vulnerable to jam attack. Jam attack means.
Are you able to shortly say where each of those two controls run?
Excuse me, can you repeat?
Are you able to shortly say now where those you said there are two controllers.
Yes.
Are you able to say where both controllers run now? I mean shortly. I don't want to create a digression for your presentation.
Let's let them do the specification first. I think we should discuss these after we see them. It's really hard to tell.
Sure.
I mean, I know the paper, but I think let's see what it does and then discuss.
Okay.
Yes. I will give introduction about this two controller. So here is the specification. This is SCP framework. So this framework is to my opinion, is basic feedback, and it has something called congestion header, and in the center, it will set up this congestion header. And in this long-fed network, we will go through very XCP routers. And in these routers, this router will modify the feedback in XCP congestion headers. And finally, this package with this congestion header arrived at receiver, and the receiver attached this header to some acknowledgement package and return back to the sender, and the sender later can use this acknowledgement to set up its later congestion header. So this is the basic procedure that XCP to control the congestion. And this is what I'm talking about. This is the congestion header. So it has 3 sections. The first 2 sections is filled by the senders. The first one is set the sender's current window size, congestion window size, and the second one is set to the sender's round trip time estimate. So the sender will use later acknowledgement package to calculate all these things. And the very last one is called feedback. And this feedback will be modified by the routers on the way to the receiver. So this describes some behavior of XCP senders. Just like XCP sender will set up the congestion window size in the header and estimate RTT in the header and initialize his demands about this feedback. We want to increase or decrease. So for the XCP receiver is very similar to TCP, and the only difference is XCP receiver will attach its congestion header to the acknowledgement packages. So here is the 2 controllers. So the first one is efficiency controller. This controller is actually for aggregation control. It's controlled the whole flow behavior. They use very simple linear combination for this control. So this file is aggregation feedback in number of bits. This means the bits you want to change later in your bandwidth. So this alpha beta is some constant, and S is the spare bandwidth. What is spare bandwidth? This means that your current input rate, and we have some capacity of the link. And this spare means the difference between your input and the capacity. So this gave us something to increase or decrease. If this S smaller than 0, that means we want to decrease the rate. And if this S larger than 0, that means we have extra bandwidth to increase the rate, right? And in this equation, we also want to consider some Q sets. Here, the Q is called persistent Q sets. What is persistent Q sets? Persistent Q is called, this Q is not drained after 1 RTT. So we have some Q, but after 1 RTT, this Q drained to 0. But this persistent means it doesn't drain. And
so what are the units of this? This is bytes, and what does this phi mean for this sender?
This phi will means the change of the window. You can, the number of the bits you can give to the change of the window. Later you want to change on the sender. You want to change the window size, right? So this phi gives you something.
And what if, and every router records this? I don't quite get it as described. There are 10, let's say there are 10 routers en route. The first router computes phi 1 and writes it into the packet. What does the second router do? It overwrites that or appends phi 2?
It will overwrite by every router. So,
and what if phi 5 is higher than the previously computed phi, or lower than the previous, higher than the previously computed phi?
So
I've gone through a bottleneck, phi 2, who doesn't want to increase the rate. Now I go to phi 5 and says, yeah, go ahead and increase the rate as much as you want.
So I think it doesn't care about the phi goes through the routers. It will override it again along all the routers, and finally give it to the receiver, and the receiver return it back to the sender.
Yeah, but that doesn't make sense to me, right? Because you want to be regulated by the narrowest, the router that's most congested. So if somebody's very congested and says, don't increase your window size, they mean that. If somebody later down the flow, further down, says, oh yeah, go ahead and increase your window size, that's not correct. That's problematic. So something has to, there has to be some kind of control law which says what to do, either append this to the congestion window or something. Let's keep going. You're not sure.
To my opinion, this is something negative feedback, right? So it doesn't matter about. So it will, in next control loop, it will modify all the things, right? If in this control loop, in one control timer, you give a wrong result,
yeah.
And in the next one, this feedback will modify it to the correct.
I don't understand. You haven't defined the procedure about what happens to phi. What happens is your
Yes. Later, the fairness controller will use this phi to control the individual flow. So this just gives you something like a bird view of how we want to control the aggregation behavior.
Yeah. It's totally reasonable for a router to compute this phi. I get that.
Yeah.
I'm not sure exactly how it's interoperated.
Yeah. So here is the study of the stability of the EC. So they give some theorem, and if we have some round trip delay D larger than 0 and not very large, and so we will, when alpha and phi satisfy this, it will give this system is stable and also independent of delay, capacity, and number of cells. So I don't want to talk about more here. If we have time, I can prove this on the whiteboard. This this uses a lot of control theory and bold plot or something. And
I don't think we're thinking control theory back then. I really appreciate it. Let's just look at the specification and see how it fits. I think we want to definitely get to the how it fits in that.
Yeah. Yes, if we have time, I can prove there. It's not very difficult, but needs some mathematical calculation and draw some plot. And so at least we know that this alpha and beta should satisfy this constraint, and we can reach stable, and this system also independent of delay. That's very critical. And here I will talk about the fairness controller. This fairness controller will use the previous phi. This phi calculated by the efficient controllers. So this policy is if phi is larger than 0, it will allocate per package feedback. So increase is the throughput of all flows in the same. So this is very similar to AIMD in TCP. So what is this AI? This AI is called additive increase. When it wants to increase the rate, it will use additive. So it means it will plus something to the rate. And if this phi is smaller than 0, it will allocate per packet feedback. So that the decrease in the throughput is proportional to its current window size. So it's called MD. It's called multiplicative decrease. It will decrease your window size proportional to current window size.
Just a second. The entity that calculates the phi and does those updates are the routers, aren't they?
Yes. On every router, we have a phi and then calculate the fairness. That means we want to allocate the results to each flow.
Okay, I just want to make sure that I understand who is doing what here. Okay.
So here they also introduce some concept called bandwidth shuffling. Why we want to use this? Because if phi is very close to 0, so this fairness controller will be stopped, right? Our policy is if it's larger than 0, we do something. Smaller than 0, we do something. But if something happens, its phi is very close to 0, so this fairness controller will be stopped. So they use this equation to shuffle the traffic. So that gamma is a constant set to 0.1. That means at least 10% of the traffic will be choose and then use this fair controller later. Right. So this H is the shuffle traffic. So every time it will choose at least 10% of the traffic and then apply this fairness controller to it. So here is how we calculate the feedback of the fairness packages. So because we have a phi larger than 0 and smaller than 0, so the final feedback on the receiver will be some linear combination of the positive feedback and the negative feedback, right? So we use this equation to get this PI means the positive feedback of each packet, and this NI means negative packages of each packages. And we use the equation 4 and 5 to calculate the PI and NI. So this is very simple. I can show you how they get this. We just do a little simple math and we can get this one.
I think we should study the laws offline. I don't think we should dive into the laws and the math. I think we should. It's not important. What's important is what the high-level goals of this are and whether it's a good fit with XIA.
Yeah. So we can use this two equations to calculate positive feedback and negative feedback, right? And at very last, on the receiver, it will get something like H feedback, and it will return this feedback to sender, and sender will use this to calculate it window size.
I'm still a little bit lost about the phi, and I'm looking at the paper, and it doesn't add much clarity, but I still don't understand how this aggregate feedback is computed. It definitely is saying what you said.
Yeah.
Each router is computing this phi.
Yeah. Yes.
But I still don't understand how it goes back into the pack. How does there's still on a 10 link network, there are still 10 different phis being computed. So I just don't get how that's going back.
That's why we have this PNN. So we have a lot of phi, right?
PI is per packet? What's the I?
Yes, it's per packet.
Okay.
So we have a lot of router 1,
Yep.
2, and on every router we have a phi.
Yep.
And if this phi is larger than 0, then we will have a positive feedback. If we go there, this phi is smaller than 0.
Yep.
We have some negative.
Right.
Negative. And in this header,
yep,
we will keep update this. We use the linear combination of this. We plus and minus, plus minus, plus minus, and finally get to the receiver.
Those
like
I's
that.
are over routers or over packets?
Per packet.
So what you're drawing is over routers. I still don't get it. Okay, so let's go really slowly for me. So I'm really slow. I'm not getting it. Okay, one packet goes through the network. Well, first packet goes through the network. You have this R1 where phi is greater than 0 and phi 2 is less than 0. What happens? What feedback comes back to the source?
So it will give a positive feedback.
Okay.
It will get from EC, right?
Yep.
This from fairness controller.
Okay.
And it will give this package or this flow a positive.
Why will R1 give that packet a positive indicator?
Because this phi is larger.
Okay, fine.
So this means we have.
Okay, I got it.
Yeah.
And now the packet goes to R2.
Yeah.
And there's phi. So now the phi in the header is positive.
So you want this to be positive, right?
No. You just said the packet is getting a value of phi, which is positive.
Yeah.
Okay.
Yeah, and here on this rotor,
Yep.
this phi, we calculate this phi again.
Yep.
And this phi is a negative, shows
Okay.
we don't have much bandwidth for this rotor, right?
So
And,
what happens to the packet?
and then we use fairness controller again. This fairness controller can also calculate some negative feedback. And we will finally use is that H feedback in the header. Do you remember we have some Windows app, RTTN, finally H feedback. So it will use your previous positive feedback minus your negative feedback. Let's use some linear combination to find this final feedback. This one will keep updates. If we have router 3, this will find something larger or smaller.
Okay, I'm lost. Pretend I'm a 100 level student. Show me the variables that are being used to calculate this. Where is this PI and the NI residing? I really don't. Draw a really clear picture so that I can see. I'm sorry to put you through this, but I don't understand. I really don't understand.
Yeah.
Draw it really carefully so I can see every single step and follow your work.
Yeah.
Every single step.
So this is the sender.
Okay.
Sender will set up a header.
Yep.
This one is the window. It's current Windows.
Okay.
We call it I. We can give it I. This I flow right.
Yep.
And we have RTTI
Okay.
and have H feedback.
Okay, which right now is initialized to, I want more bandwidth. Is that right?
So, yes, I want more bandwidth, and we set it to go through this route and go to router 1, right?
Yep.
And here, we can use that efficient controller to calculate a phi. Right?
Okay.
That efficient is equal to alpha average round trip time and equal to the spare rate, right, minus beta, and this is the queue size.
Okay, good. So let's put the phi 1 and the phi 2s next to the routers. Let's imagine those are not changing ever again.
Yeah.
So those are constants. I think just write them and put them in a box. Phi 1 is greater than 0 and phi 2 is less than 0.
Yeah.
Fine.
Phi
Right next to the router, so we can see where it lies.
Okay.
That lives on the router. That's computed and done at the router, right?
One more question. D is the RTT of...
D is the average RTT. So it's not, so it will estimate the average RTT of, and we will use some RTT equals to RTT plus some weighted RTT and get some average.
The router knows that.
It sees it in the packets that go by.
Also, it's a field in the header.
Yes, every time this sender will set up 2, and this 2 never change for one control timer. So if acknowledgement return, it will modify this. It's only modified by sender, and this feedback is something this. It's modified through the route or on the way to the receiver. It's modified by each router. And here we have some phi larger than 0. And okay. And these packages have these two variables, the sender set, and we can use this equation here to calculate, according to phi, to calculate the positive feedback.
Okay, so PI is a computed quantity at router 1 comes, and now we compute PI.
Yes, we use these 2 parameters to calculate this PI. You get this PI on this router.
And NI also. Same thing. You also get NI.
No, we don't got NI here.
Yeah.
Yes.
Yep.
Because we calculate according to this phi.
Okay.
Right. So it goes along and arrive at R2, router 2. And here we got phi is smaller than 0.
So wait, you skipped one step. So router 1 rewrites the packet, and it says CWindI, RTTI, those go through as before.
Yeah.
But now it writes in PI into the packet.
Yeah. So we have packages. CWNDI, Windows says RTTI. And we have this, we suppose we don't have previous one, right? So this one will equal to PI.
Okay.
We suppose this one should be 0 or something. It will give something that will override by router, right?
Okay.
And then this package just goes along to the router 2. And we use efficiency controller first. And we found that this phi is smaller than 0 right now. So it will use fairness controller again and calculate NI here.
Okay.
We have this right.
Yep.
And here we put in the packages what we put. Here will be feedback equals to PI minus NI because this positive is negative.
Yeah, that's a really weird notation to me. So each feedback equals PI minus NI.
So
it has
this
the
is-
impression of making it seem like those are local. The scoping is really weird. It's saying use the previous PI and take my current NI, which I've just computed, and subtract that out and put that in the packet. I guess that's what. Is that really what it means?
So we pay attention to this two constant.
Yeah.
They update this constant every control timer. So we suppose we calculate all this, and then in my next slide, it will update this. So this time you. Okay. So the order is very hard to describe, right? On this one, you have a 5P, not CP and CN. And when you finish the control, you will update this too, and to use later. And when the acknowledgement back to the sender give a new packages, it will use the update one.
Okay, thanks. Now I understand what's coming.
It's really
complex. I think. I'm still not totally confident about PINI, but I have.
So this is also my understanding,
right?
According to this paper. So
right.
So
no, you did a good job.
Their models. For now, this is my understanding. Maybe.
I agree. It's not crystal clear in the paper.
Yeah,
look at too. So what you've done is a faithful translation of the paper.
Yeah,
I agree.
Yeah. So for every control timer, we update this positive feedback constant, CP, and CN, right? And we can use it later to calculate PI and NI.
Yep. Okay. It's not screen sharing anymore. If you want to screen sharing.
Oh, sorry. So I think I must misunderstand. I must confuse Michelle a lot.
I'm trying to follow you, looking at the paper.
Sorry. So we will update the positive feedback constant, CP and CN, when one control timer fired. And so I think this is the whole control flow of XCP. So it's finally, these packages will arrive at receiver. At receiver, we have this H feedback. It will attach this header to its acknowledgement packages, return back to sender, and to let sender can calculate its new header. So it will modify the window set so the read to be controlled. So here, in their paper, they also gave some modified efficiency controller to achieve TCP friendly.
I think in the interest of time, we should skip this. The literature agrees that they did it. So
so really simple. They just use this weight to let the window of the XCP converge to the TCP. So TCP friendly means you can't have more bandwidth than TCP, right? They try to use this weight to let the window sets converge to the TCP window.
Yuguang, is it correct to say that being TCP friendly here, it's optional?
It's not. I think we want our protocol, our principle to work along with TCP because TCP is dominant right now.
Well,
a question about XIA or XCP?
My question is, if we had XCP implemented in XIA, being TCP friendly would be optional, wouldn't it?
Yes. I mean, that's a value judgment, whether you want XCP to operate like TCP or according to some other different rate.
Well, I'm more interested in the question, can XCP have a better usage of the infrastructure if it's not TCP friendly? Because now we are just assuming that being TCP friendly it's the way to go, at least for what I get from.
That was a major goal in the early 2000s, that if it couldn't be TCP friendly, it was problematic.
Yeah.
So that's why they're doing that exercise.
Yeah, this XCP is, for my opinion, is much better than TCP, but it must be TCP friendly because most of our applications use TCP.
Yes, but if we don't have a TCP on XIA, I don't see the point why we need to be TCP friendly.
Yeah, so they must consider this in their paper because they want their XCP can be deployed on our internet. So they must have some idea to achieve TCP friendly.
Okay.
So this is TCP friendly. We skip this part. So here I will show you the simulation results. I will show you 3 different results according to bandwidth, according to delay, and according to number of sources. This means the number in the flows. So in their paper, they also do a lot of simulation. If you're interested, you can take a look at that. They also do the simulation about the short TCP flow. It's something like the web transient TCP connection. So I only show this 3 because I think this is most important and can show XCP is outperformance. And here, they, according to the theorem 1, they choose alpha equal to 0.4 and beta to 0.226. And they compare XCP with 4 different active queue management in TCP because TCP will have a lot of queue and it will use some queue management. This is the 4 queue we use to compare with TCP, with XCP. So the first one we can see here is the bottleneck capacity. This means the bandwidth. So as long the bandwidth go larger and larger, and the TCP goes down. So that's me. And we can see that this is the bottom utilization. This means that's works by the efficiency. This is show the efficiency of the XCP. So when the bandwidth increases, the efficiency down TCP. And this one is the Q size, the average Q size. So we can also see that when the bandwidth goes increase and this XCP queue increase smoothly, and you can see the TCP very sharp up and down. And this one is this is about drop rate. So TCP will drop packages, but XCP seldom drop packages. You can see all there. So when I see the result, I'm shocked. It never drop packages. It's super good.
What's the topology?
What's
the topology of the SOA? What's the network? What's the network look like? What is the simulation?
Yeah, I don't pay much attention. They just say they simulate all this according to the author's paper. So I don't much experience about that deployment, and so I just see the result.
Right. So, and these are strong authors, and they know what they're doing, but this is really critical to know what topology they're deploying it over, because you can get different results on different topologies. They had 2 in their paper. One's a line topology and one's a parking lot topology. The choice of topology is really quite critical. So
they used, I think for this really use very simple topology.
But don't be in general.
Yeah.
If you're looking at a paper and seeing optimistic results, so I'm reviewing SIGCOMM papers this year, invariably, very often, you see very, very positive results. It's hard to interpret. You've got to take your own critical judgment and think, are they comparing the common case, typical case, a rare case, a case that favors their work?
Yes.
A case that shows the weaknesses of their work? What? this result section I think is done reasonably well, but I think it's hard to look at results and say this is great without understanding kind of deeply what's going on.
Just for now, I'm sorry that I don't know which topology to use because I don't have much time, right? I only have 3 days to finish off.
Oh yeah. No, you're doing a ton of work, and don't get me wrong.
Sorry, and I will make clear of all this and clarify this in our group email and to let it you know.
No, you don't have to. You don't have to. I just think maybe the simulation results are. Since we're doing this in such a short and compressed time, I don't think we have to completely understand all the simulation results.
Yeah.
I'm completely convinced that XCP is working well in all the topologies. I think what we should do for the purpose of this XIA meeting is just to say, okay, this is a really promising congestion control method. Here's the specification.
Yeah.
They show results, and then the next decade has shown that this is a reasonably good protocol. We're not going to go into those details. Let's see if it fits with XIA. If it does, then we can really drill into the simulation results, the fine details in the paper, and really figure out what we need to figure out.
Yes.
So I think in the interest of time, I think we should skip over the simulation results and skip down to the last part. This.
Yeah, so this is, I came up some idea about why XCP is good for XIA. The first one is, this XCP is to me, is very mathematically simple. They use linear combination, and their controller is very, very simple, and also stable. But when they use this two controller, they make it very efficiently. So I think this XCP is very easy for us to implement. In their paper, they gave some pseudo code. There's very few line can implement XCP control. So this is the first advantage. So the second one is it convey all the control information between in-system and routers. It updates all the things on the router. So this is give me some hint that whether we can put some XCP principle on each router and to do the same thing. Can we? I just have this idea, and we can also use header, but I don't think that's a wise choice because our XIP header is very, very large, right? So if we attach new header to XIP packet, it's not a wise choice. So I prefer to use principle. So we can put XCP principles on the two endpoint and on every router. So this XCP principle will do its job. It will update feedback and at very velocity will return back to the centers and do the same things, I think. And the third one is this XCP efficiency controller is independent of delay capacity and number of thoughts. So that's why I think this XCP is very good for global congestion control.
I have a couple of observations.
Okay.
To say that it's good for global, you should be able to kind of easily say something like, is it going to work for content, for example? Because if it doesn't match at least content, it probably cannot be global.
So I mean, we don't care about other principles. That's XCP.
Well, my point is, you can only say it can go global if you have a story for any possible principle. I'm fine with XCP being the first exploration of our congestion control. I'm just troubled by saying that XCP is good for global. It may be. I just don't see it right away being the case.
Yes, you're right.
And the second thing, I don't know if it makes fully sense to have a XCP principal, because from your presentation, I don't see any identifier that it's being created. I see a header, but not necessarily something addressable. So it wouldn't be a network factor as we.
That's a problem.
Yeah. I'm not saying it's a killing problem. I'm just pointing that there is a mismatch here. So at least my suggestion would be to figure out what we truly need to have some version of XCP in XIA, and see from that kind of specification if we could even poorly map it to a principal. I'm not saying it would be a good, but at least for having some experimentation, and from there move forward. But those are the two main comments that I had. One, that the issue with the suggestion with being global, since it's not obvious that it would work for all principals, and the fact that we at least the way it has been presented, we don't have identifiers, so it cannot say it's a network factor.
So can we make some identifier for XAP? We can just make XAP principal to do its job. So we can let it run on the top of every principal and control.
It's too optimistic. I don't see how that's going to work. But Cody, I think Cody, let's take questions from the field and discuss.
Okay.
Yeah, Michelle, I was thinking in terms of your question about identifiers.
Yes.
Maybe it would be possible to have the identifier be the ID of the receiver, because most of the principals anyway, right? They route either depending on whether the identifier is local or if it's somewhere else. And so obviously, if it's somewhere else, that means you're at an XCP router. And so it would be one algorithm to follow, right? And if it's local, that means you've actually gotten the receiver and would follow the other action of sending the ACK back to the sender.
That's a starting point. My question is more really toward to make sure that we have this identifier, because at this point it's not clear that we can use it. I would definitely look at those identifiers you just suggest for the endpoint.
Okay. Right. Let's see if there's really a fit here. I think we've got we have a high-level understanding of what XCP is. I don't see them really identified what the key issues are with connecting it to XIA. So let's go back and look at XCP at a high level and think about if it really connects to XIA.
Mm-hmm.
Okay. Here we've given some advantages. So
you do this one.
So what is XCP requirements? Like, what do we need in order to have XCP? Okay, so I think the advantage, I think is well articulated, is that it's simple, relatively simple and mathematical, so it's easy to conceptualize, even if it's a little hard to understand the details. Okay, we need one thing that's always been a limitation of XCP and similar protocols, and this is really a big sticking point, is this notion of maintaining per flow state at routers. So we need to maintain these average window size, the average congestion control size, the average for every single flow that's going through this router.
Yeah.
Okay, this is the gigantic elephant in the room. This is enormous. Nothing like this exists in the current architecture.
Yeah, yeah.
Okay, so this, like, whenever you talk about XCP, like the first slide says, this is going to be a really simple, nice, TCP-friendly protocol. It's going to have a per flow state. It's really a departure. Your talk's very good. I mean, thank you for presenting it essentially. But it's a little optimistic.
Yeah.
It doesn't. We haven't heard about like what issues.
Yeah.
Like, why is it? If this is so amazing, what's your talk?
Yeah.
Why it should have been deployed in 2003?
Yeah.
Why
Yeah.
was it at TCP?
Yeah. Yes, I think it's much better than TCP. Why we don't use that?
But it's got enormous deployment issues associated.
Yeah.
Cool. Per flow state at every router. Cisco said, XCP? Okay, no way. Absolutely out of the question.
Yeah.
Software-defined networking? Maybe. Juniper router? Forget about it. We're not going to do that.
Yeah.
You know, this is a gigantic, enormous consideration. I think it's possible. I mean, maybe today in SDN context, XA over SDN, maybe you can think about some type of per flow state. Okay, so for XA specifically, this notion of XCP has kind of a notion, again, of a path. We've seen this before. There's a very TCP-centric notion inside XCP of flows starting with a source and ending with a destination. And I think this is what Michelle and Cody are pointing at, that does XA have that? Not really. Sometimes we're just routing to a CID. Sometimes when we're emulating NDN, the source address could be blank. How in the world is XCP going to work if the source address is unknown?
Yeah.
I mean, there's no way, right? Because the source address, that definitely implies the source is not going to be putting things like congestion windows and round trip times and packets, because that's information revealing. So it definitely is not, there's no way that XCP could be a global, I mean, it could be a very broadly used congestion control protocol, but globally, I don't know. I'm not sure what NDN is doing for congestion control for that matter either. That's the part relevant. I think for content, as Cody was saying, I think if we put the destination as the ultimate intent, I think that makes some sense. For most routers, if we're computing these values using XCP, using this destination, and probably, I mean, probably pairwise, you would want the final intent in both the source and the destination to be used to measure this feedback parameter. But I don't see why that's totally unreasonable. That would work in many cases. Michelle, what do you think?
I have to think it through. I was really making the case that we need some sort of identifier.
For HID, I think it would work directly. If it were the case that the intents on both endpoints were HIDs, that's very in line with XCP. If the ultimate intent originally is an AD, maybe, probably. If it's a CID, I don't know. It depends. If that's,
I think what we are missing at this point is to say what is the exactly transport protocol for the CIDs.
yeah.
If we were able to say that, maybe we could make a judgment for here, because the CID transport is not fully defined at this point. I mean, we have the Click XIA have a story for it.
Right.
I don't know if they have fill all the items.
Right. I think the XCP worldview is really kind of like this. You're a router, there's a source, there's a destination, these guys are running some control algorithm. The destination's not doing much, it's just sending ACKs, it's not doing a whole heck of a lot. And the router has per flow state. If this is your world, where the sources are sending relatively long-running flows, the destinations have the capability to respond, and the routers have the potential to update packets going through them, to the extent your world complies with that, you can run XCP. If you violate these assumptions, especially the one that's most in risk of violation is I don't know that this notion of path is really operative.
I think the constraint is not about the path, but if you are able to identify some sort of flow.
Mm-hmm.
But
it has to go along a path. It can't be that the flow is moving, right? It can't be that it's an SID where every time you send a packet, it's going somewhere different. Now it doesn't make sense anymore.
Well, let me put it as a question. Is there a way to conceive a flow for a multicast tree?
Yeah. Yes.
How XCP router would do it?
Flow, because there's no conservation of flow in multicast tree. No, well, I don't know. It depends what you mean by flow. Right? Multicast trees abuse flow because flow typically means conservation of flow. Number of packets coming in is equal to number of packets going out. And when multicast trees replicate packets, that's not a flow anymore. From the Ford-Fulkerson definition of what a flow is.
Okay, so XCP cannot apply for multicast.
I think people have tried to adopt XCP in some form or another for multicast, but I don't think this paper has done that.
At least look at that kind of how they did with multicast can give us a clue how we could extend XCP for other principals.
Yeah, you're right. This violates the XCP framework because it's no longer a single source, single destination object that you're controlling. Like how would you get these feedbacks back to the source to regulate a single set? That doesn't. Yeah, I agree. No, so XCP is for one-to-one communications.
If XCP works poorly for multicast, we know just as from that fact that we probably cannot extend XCP for the other principals.
Yeah, I think XCP is for point-to-point communications.
Would we be able to say, you can use XCP, but there's a restriction. You would first have to bind, your content or service to a specific host. Then you can do it.
If you have those restrictions, it would be probably implementable in XIA, but it could not be the global solution.
Yeah.
I've got to go to a talk, but let's just think about if it were implemented in a point-to-point context. I think my sense was similar to yours, Michelle, that it isn't a standard principle. It's not in a DAG. It's something, it doesn't even rely at the XIP layer. That was in Yuguang's talk as well. It relies logically above that at the transport layer. So it's a principle, but not in the XIA sense of a principle. It's some kind of stateful shim layer or thin layer, much like the XCP implementation, the original implementation looked like.
Okay, we need to think that forward and see how if there is interest from Yuguang to at least pursue it, at least see how it could be implemented for testing.
Yeah, I think it's an interesting case. The reason I pointed to it is because I think it's a very interesting case study when you want to depart from TCP and do something better than TCP. XCP offers a really, really promising alternative, but it's limited in what it can do. It has to do stuff that's over a path, it has per flow state, and you have to be able to deal with this sort of rate-based control. It's kind of still highly controlled inside a fixed path.
Well, at least in my understanding, it's not more limited than TCP.
Right. That's right.
So it's just that we may be asking too much of any congestion control protocol, but I don't see it. It probably could be a little more flexible than TCP. It's just that we may be asking too much from it.
Well, I think you'll find that there is no congestion control protocol that's going to be currently existing, or even maybe you can even prove that it's impossible, that can be global in the sense that you're hoping for. I think you have to apply point solutions to different parts of the congestion control space. Rate-based control for flows that are long-running point-to-point, something different for multicast. Maybe it might have to be, at least with current technology, it may well have to be a mishmash.
I think even if we are able to say why the global congestion control cannot exist, it would be still a valuable result.
It's either a valuable result or it's something entirely trivial that people already understand. It just has to be framed in our world.
When I say it would be valuable, it's because I don't know if at least I'm not aware of a clear answer why it cannot exist.
Right, but that doesn't mean that the community doesn't understand why it doesn't exist. I mean, someone like Mark Handley may be able, who's a real expert in congestion control, also worked on multipath TCP. Probably has a way to express in a second why that's impossible.
Okay.
Okay, I have to go. I'm very late for this faculty talk. So thanks, Yuguang. That's really great that you're able to bring this paper to us on such short notice. We don't expect you to do it so quickly.
To share a paper just and discuss later.
That's great.
Good.
Yeah.
We're going to answer some questions.
Yeah.
Yes. Given that we are all done with the XCP paper, now we can turn to questions from the GSoC student. We have at least one viewer, so if you have questions, now is a good time to put it as a comment. Anyone that is seeing this video now can ask a question on the Hangout page.
Where's Hangout page?
Well, it doesn't seem like we are going to get a question. Let's give a few more minutes and why they are writing the question or not. Let me ask you, Yuguang, do you intend to pursue XCP? Do you intend to look for newer papers to maybe answer one of those things that we discussed during this meeting? What is your idea about XCP?
So I think this XCP is really good. So when I read this paper, I was shocked by the amazing performance of this XCP. So and I also think this XCP is more flexible than TCP, right? So if possible, I prefer to bring this XCP to our XIA.
Okay, so you intend.
But right now, I'm not clear about what to do and how to do. I just
Well, I would recommend to do at least two things. One is to describe exactly what you need
yeah.
to implement. Where, for example, I need to, on every router to do this.
Yeah.
On every client to do this, and if there is any difference from the server, I need to do this. I mean, specifying, like, for someone that will get from your specification and write it easily in somewhere in XIA. It must be a direct map.
Yeah.
And the other thing would be just to learn about what followed the XCP. For example, John mentioned that someone, I don't know if it were the authors, the original authors, extend XCP to work in multicast. Learning about that lesson would definitely be an interesting thing, because it could lead us to a higher understanding how we can apply XCP to XIA.
Yep.
So those are my two suggestions. About the questions that someone, I don't know if it were the authors, the original authors, extend XCP to work. Oh boy. Okay. That the sound that you heard was because I was trying to get the questions from the YouTube comments. So okay. Garnauk have a few questions about implementing LPM principal. And here it's thinking about using volgrind toolset for evaluation of the algorithm. Wrapping volgrind inside the bash script could easily help us to monitor the working of the algorithm. Could you please comment on this suggestion? As far as I know, volgrind is used as a debugging tool. So you run algorithms, run software, and you measure global things like memory allocation, if the code is doing something that you consider misbehaving. But as far as I know, volgrind won't give you inside measurements. For example, if you are using it for evaluation, the long prefix matching algorithm, it won't take you the measurement on how much time each query was, how much time each query took. So volgrind probably wouldn't give that kind of information, any other measurement that goes inside of the algorithm. So unless you can explain how you would do those kind of internal measurements, volgrind wouldn't be the whole answer. It could be part of the answer, but definitely not the whole answer if you cannot take an inside measurement. Let's see if I find another question. And that was the only question that we received. So if we don't get one more question in 1 more minute, this meeting is gonna finish now.
Michelle, I know John said in the past that he wanted us to all present some ideas first, and then he would talk about some ideas too. Should we ask him for next week if he wants to give a brief talk about what he thinks?
Sorry, I didn't follow. He asked in the past to present?
Well, when he was just asking everyone to come up with a research idea.
Yes.
About a month ago, he also said he would have a day where he would present some ideas, but he wanted to see what everyone else had to say first. Should we ask him if next Monday would be good for him?
We can definitely ask.
I mean, unless you have something else for next Monday.
Well, for next Monday, we have, I mentioned it in one of my emails, but it was a side note, and I intend to send an email about it. Friday this week is the deadline for the students to submit the GSoC application.
Oh, right.
And I expect that all mentors will evaluate the applications on Monday. And they would have at least the meeting time to do that.
Okay, that makes
Let
sense.
me even extend a little bit for the other students that may be listening to this video or listen it later. Each proposal that we'll receive up to Friday will have at least 2 reviews. So at least 2 different mentors will review each application. My general idea is that each mentor that will be allocated to a project will review all their proposals to that project. So let's just assume that, for the sake of example, that I'm the mentor for to extending OVS. I will review all the projects for OVS. And in order to balance the work among the mentors, there will be like a number of proposals that everyone has to review, and I will review that number, a few more proposals up to get to that number. So everyone reviews about the same for the number of proposals. After we get 2 evaluations for each proposal, then John and I will evaluate which proposal we may want to look further. And either I or him or some other mentors that we ask will do more reviews of those proposals until we get to a list for all the proposals that we want for each project that is listed. If there is one project that was suggested that wasn't on the list, it will be another project. But at the very end, we'll have a list with, okay, for this project, we want this proposal. And from that list, we will finally create the final list that will be the priority list that is going to be sent to Google. Because Google doesn't say to us how many students we are going to have. We need to provide a list to say, if I give you 2 students, who are they? So that answer will be finally answered by the priority list. And that's pretty much how it works. It will work.
Okay. Sounds like we'll have our hands full next week then.
Yeah, so next Monday, I will send this email either today or tomorrow explaining everything, all the details for the mentors so they can work on the. There are a few proposals already in, but I don't expect any mentor will put the time to review those now because the number will grow up to Friday. So from Saturday on, the mentors are supposed to do the reviews, at least the first phase of the reviews. So yes, for next week it wouldn't be a good date. But you definitely could ask John if he wants to present something. I also remember now that you point out that he said that. Well, he was very clear. He doesn't want to taint our view for how to pursue the research. That's something that he has always done. So I'm just thinking that he may not want to present that to make sure that we are not pushed in a direction just because he said it. Yes, but we don't have a topic meeting, a topic for the next meeting, skipping the GSoC evaluation. Okay. So if someone, I expect that some of the meetings that we are going to have next will be a byproduct of what we are doing. I mean, we are going to be working on some subjects, and they will naturally generate topics for the meeting. I just expect that you will send those topics to the mailing list with a few days so people at least know that you intend to take the time to discuss those topics. And probably there will be at least a few weeks that we won't have any topic at all, and that's fine to not have a meeting once in a while. But once each mentor is assigned a student, even if we don't have a weekly meeting for the project, you may want to dedicate some time to your students, so you have a one-to-one time to answer a specific question or guide them. Let me see if we have one more question, otherwise the meeting is over. There is one comment that I need to address here. It's from Andre. I will just read his text. Hi, following up on my question about multiple proposals, my idea is to execute one project, but there is more than one that I'm interested in. I'm only applying to the Linux XIA team project, and I'm trying to increase my chances. I don't know if everyone read my answer to the mailing list about his question about applying for multiple proposals. Let me emphasize, I'm not saying that you can or should not apply for more than one project. I'm fine with that. My answer was just focusing on making sure that you understand that at the end, what is more worth is to have a stronger project than have many projects. Because all the mentors are going to be looking for strong proposals. So if you allocate your time to have 2 weak proposals instead of have one strong one, that strategy will be very, very bad, because your 2 weeks proposal will be essentially outrun by stronger proposals on those 2 projects. Having said that, if you have finished your proposal, you cannot improve it further to make it a stronger case, and you are interested in another project, and you have the time to make it a worthwhile proposal, you should definitely go for that. I see no problem on having 2 strong proposals. I was only trying to make it clear that it's not worth the time to spread yourself thin on every project, because at the end you would end up with weak proposals, and weak proposals are not going to make your case any better. Let me see if we have one more comment or question. Okay, that's all we have. So the meeting is over. Thank you very much for your time, guys.
Thank you.
Bye-bye.
Bye.